everyone, thank you for joining us today. I'm Virginia, one of VALVEcampus organizer. We are very happy to welcome Daniel Führer, Technology Manager at KXAG, and Thomas Iberio, Assistant Technology Scout. Today, talk about the hydrogen economy. The last minute of presentation will be the question and answer part. Please write your question in the chat box. It's now my pleasure to present Daniel Führer. Thank you so much and have a good webinar. Hi, Daniel.
Hello, it's Daniel here. Nice to meet you, everybody. And it's a pleasure for me to introduce you a little bit into the topic of scaling up the hydrogen economy. And hydrogen, I think it's a topic where a lot of is discussing at the moment. In Europe, there's a lot of discussion, especially in the fields of the European Green Deal. And one important pillar is the field of the hydrogen. And what we see today, hydrogen production, hydrogen utilization, hydrogen infrastructure technologies are heavily subsidized today by several billion euros. But on the other hand, we also see that the prices of components and systems are not competitive. It's much too expensive. Beside the prices, there's a lot of let's say white spots in the field of norms and standards for hydrogen components. A lot of companies say, okay, I'm in the field of gas. I try to copy now my knowledge from the gas sector into the field of hydrogen. Really often this also works, but in general, also all over the world, there are no fixed standards and norms. And in these fields, companies really have a good opportunity to be part of such a hydrogen economy. And in the last year, we, the KXAG, together here at the campus of the RWTH in Aachen in Germany, try to focus how can I industrialize this hydrogen economy. Short introduction from my side. My name is Daniel Führer. I'm Technology Manager at the KEX Knowledge Exchange AG here in Aachen in Germany. And we, the KEX-AG, we are a professional provider for technology and market information. And we are a spin-off company from the Fraunhofer Institute for Production Technology. Maybe you heard about it. And we had we spun off 7 years ago, and we try to help companies by doing the right innovative strategies. And especially in 3 different pillars, we try to help these companies. One pillar, the additive manufacturing, the other pillar, the artificial intelligence, and on the other side, the hydrogen. And maybe who we are. So the KEX is as I said, a professional information service provider for technology and market information. And there are often a lot of questions, especially in the field of new trend technologies, where companies like you, for example, said, okay, it's a really interesting topic. There are a lot of information all around, in the internet, in lectures, a lot of interesting spin-up companies. But now the question is, okay, is this trend really relevant for me or is it not? And maybe one sentence where we try to help you is the example of the internet. When you take in the internet, then looking for relevant information on the internet is still like taking a sip from a fire hydrant. So a lot of companies have the questions. There was so much information. They don't really know what are the right information for me and what are information that are not relevant. And here we try to enable you to make faster and better technology decisions and future-oriented innovations. Where we are located, as I said, our main quarter we have here in Aachen. You see here on the left of Germany. It's directly at the border of Germany, Netherlands, and Belgium. We also have 2 additional locations here in Germany, in Berlin and in Munich. But what we also know, Germany is not the middle point of the world, also not of the technology or innovation world. And what we see definitely in the last years, the Asians, or in China especially, there is a lot of innovation, a lot of fast innovation that's going forward. So it's really important also to understand the market there in China. So we also have their location where we started this location 2 years ago in Hong Kong, to also take a look now in the Chinese and the Asian market. And what we also now we want to do is to have also an international hub in the USA, in Boston, and we try to build this up also this year. Yeah, technology and market trends. When you take a look every year, maybe in the newspapers, there were a lot of technology and market trends. And maybe 5 years ago, one of the main trends were in the field of the additive manufacturing. But at the moment, there are a lot of trends on the market which has to be discussed. We talk here, for example, about digital production, about retrofitting my existing machines. We talk about zero waste, means sustainability is getting more and more important. Then the field of personal health care is really important, and one of the additional really important topics so far is the field of the hydrogen economy. The hydrogen economy. Why is it so important to understand these fields, and why does hydrogen will take a really important part in the next year in our everyday life? Especially in Europe, there will be a major transformation for the European industry. The EU said, okay, by the year 2050 we want to have a net zero emission. So it's a concrete European climate law. And here a lot of companies we have discussed with, for example in Germany, ThyssenKrupp or also Covestro, they said, okay, 2050 we have to be we need net zero emission, and we also know with our existing technologies this will be not working. And they take a look also what technologies are needed, and when we have an overall picture of this, then we say, okay, hydrogen will be one pillar to realize such a net zero emission. And when we take a look, for example, in this European Green Deal, then you see a lot of ambitious statements. So a zero pollution ambition for a toxic-free environment, then preserving and restoring ecosystems and biodiversity. So a lot of clear statements are there, but in general, it's really hard to realize this deal. And when we take a look, what needs happen, what is needed to realize such a deal, then we see that the necessary decarbonation is needed, especially in the sector of mobility, in the field of energy, in the field of industry, and also in the field of materials. So sustainable materials will be more and more important. And you see this net zero emission by 2050, a really good goal. Let's say everything has to be green. We want to be the green European country, but now the question is, how can we realize this? And when you take a look at this picture here, at this diagram, then you see at the moment the hydrogen production, you see it's not really green, because this called gray hydrogen, which is based on fossils, dominate the market so far. And of approximately 96% of the hydrogen produced worldwide is gray. Gray means by natural gas, by crude oil, by coal, and so on. And only 4%, so a small part is realized by green hydrogen, meaning by technologies called electrolyzer technologies. And for sure, when we think about the next step for hydrogen, it has to be green. So we have to develop technologies to realize such a green hydrogen production, means without CO2. And we need to realize that this green or CO2-free hydrogen production has to be also competitive compared to the prices of these gray hydrogen. And this is one of the major goals we have here in Europe. And this will be also one of the major advantages here in Europe, also compared to other countries like America and China. Because here we have really good technology know-how in Europe, where we can really develop good production technologies, good material developments. So it's really important to start now these green hydrogen, these CO2 hydrogen developments. And when we also take a look here, you see on the right a picture of the estimation of the hydrogen conceal. This estimates the growth of the hydrogen demand worldwide to a value of about approximately 550 million tons of hydrogen in 2050. And when you take a look where we stand now, so it's approximately more than eightfold of such an increase. And here you see also definitely that the hydrogen is really needed also for next product developments in the fields of mobility. You hear now a lot of in these fields. Mobility is one of the key drivers for hydrogen so far, but when we are honestly, we can buy such a hydrogen vehicle, but for example, such a Toyota Mirai costs approximately 70,000–80,000 euro, so nobody will buy this. And here's really the goal, to decrease the production prices, for example. And yeah, this is more or less what we saw in the market of hydrogen. And 3 years ago, we started here in Aachen our activities in the field of hydrogen. And we started the field here with the question, how can I industrialize a fuel cell? So the utilization of hydrogen. And here we started with companies like automotive supplier, like Toyota, like Ford, like Daimler, together with automotive suppliers, tier 1 suppliers, like Siemens, like Bosch, like Rheinmetall, to develop potential technologies to industrialize such a fuel cell. So the big goal to decrease the prices. That means we develop new designs of fuel cells. We're going also directly into prototyping to really have clear data. How can I decrease the cost of such a fuel cell product? But now, I would say such automotive OEMs say, okay, we are ready for market entry. But when we are honest now, for the hydrogen economy, let's say it's nice to have such a fuel cell system that is maybe good in a price, but everything before this hydrogen utilization, means the hydrogen production and hydrogen infrastructure, it's definitely also important. Maybe it's also much more important to realize which technologies can be realized and how can I decrease the price. And this is at the moment the step where we are in Europe. We try to build up more or less a good hydrogen infrastructure. We develop at the moment hydrogen production technologies for green hydrogen, but we have now the goal to decrease the prices and also to develop and realize norms and standards for this new hydrogen economy. These norms and standards are at the moment not available really. So there are some associations who say, yeah, the standards and norms from the gas sector can be copied to the hydrogen sector, but that's not true. That's not that is not realistic for 100% of products and materials. So we really have to think about new standards, new norms that can be integrated in the hydrogen economy. And for sure, you can also imagine that will not work with only one company. Here we have to build up a really strong network with strong companies, with strong research institutes, to really say, okay, we build up now a product, a material for hydrogen, and say, okay, this is now the standard for us in the field of hydrogen production or hydrogen infrastructure. And what does it mean really? So what are typical components in such a fuel cell system, in such an electrolyzer system? Typically, it's divided a little bit in the balance of plant. That means the overall system, and the stack component means there where the hydrogen and the oxygen are reacting with each other. And when we take a look at the balance of plant, especially, then we see there are a lot of components and a lot of know-how that have to be built up. So we talk in these balance of plant about hydrogen tanks. We talk about air compressors. We talk about electric motors. We talk about batteries. We talk about hydrogen lines. But what we also talk about is, let's say, maybe these smaller components called sensors, pressure valves, rectifiers. This is also a really important point. How can I build up a lot of sensors, a lot of valves for my hydrogen economy, and what are these standards and norms for these ones? And the same for the hydrogen infrastructure. So we need standards and technologies for storage and distribution. So here in the field of storage, you see, I call these hot topics in the storage sector. About, I think it was 95% about the storage is done by a pressure storage or pressure tanks. But at the moment, there are a lot of discussions, how can I increase the energy density of such storage tanks. And here we talk also about material-based storage, like liquid organic hydrogen carriers. We talk also about cryogenic tanks, so with really low temperatures in the field. And in the field of distribution, we talk about developing of new material pipelines. We talk about the big problem of hydrogen embrittlement. So you have to think about hydrogen, the smallest molecule. So there is a lot of problems or challenges in the field of materials. We talk about fittings and connections, and we also talk about retrofitting of my existing infrastructure. So for sure, it's a goal maybe to use these existing infrastructure for the gas sector, for example, that I can also use hydrogen in these infrastructure. But the question here is, how can I do it? Can I do it without a problem? At the moment, they say up to 10% hydrogen can be introduced in these existing infrastructure. But what's happening when the hydrogen or my hydrogen economy is scaling up? Then I need much more hydrogen. Is it maybe possible to do retrofitting in my existing infrastructure up to 20, 30, 40, 100% hydrogen? What do I have to do? And these are really interesting questions, and these questions are at the moment not solved. And in general, the cross-cutting topics are really, really important. So the most important thing, and also a lot of people are afraid about this, health and human safety. So hydrogen, for a lot of people say, okay, it's really dangerous. I'm not sure if it's working. And for sure, codes, norms, and standards to realize or to establish new standards. And the sector of sensors, controls, what can be done in these fields are cross-cutting topics as well for the hydrogen production and utilization, and also for the hydrogen infrastructure. I told you that hydrogen vehicles or hydrogen products in general are really expensive, and I would like to show you why this is the case. When we talk, for example, about battery vehicles, then you have your power electronic system. So you have a battery, you have a DC-DC converter, you have a DC-AC inverter, a motor. But now in the field of hydrogen, I also need these power electronical system, and on top I need a lot of more systems. So for example, when I want to process my fuel in these fields, so my hydrogen, I need a lot of components here. I need my tank, my pressure regulator, I need an injector, I need a hydrogen recirculation system in general, and for sure I need a lot of components, also valves, sensors, and so on. Then beside these hydrogen processing, I also need the processing of air processing. So I need my oxygen I need. And also for this, I need a lot of things, an expander, for example, a humidifier, for example, and also a compressor. So this is a really expensive part. And on the other side, I also need thermal management systems. which is also important. Heat exchangers I need, which are really expensive. So you see, this overall system is really, really expensive. But what you also see, not only the big parts are expensive, also the smaller parts are expensive, like sensors and like valves. And when we now take a look at the valves in such a system, then we see the following. Valves perform various tasks in such a fuel cell system. The injector, for example, so the injector is used for constant hydrogen recirculation and continuous called needs based supply of hydrogen from tank to my fuel cell system. And the injector must precisely control the mass flow to meet the variable power demand, and also other valves such as the drainoff valve, for example, provide clean separation of condensate, while other switching valves are required for unscheduled, safety-relevant shut-off functions. And in general, all valves have in common that they must function precisely and reliable, and extremely low internal and external leakage values are essential to ensure stable system operation. And this is one of the major parts. So small amount of leakage is only necessary, and the valves must meet the highest safety requirements through their entire service life. And this is really important that also such valves are working in this system, because, as I said, this overall system is really, really expensive. And if this is broken, then I think everyone has a problem, because then the whole vehicle for 70,000 euros is broken. So then we have really problem. And the material that are usually used, or these valves that are usually made of stainless steel, also internal components can also be made of polymers, for example. But for sure, not only in such a fuel cell, valves are important, also in the infrastructure part and also in the storage parts, there are a lot of valves in such a system. Here you have an example of a pressure tank system for the automotive application. And you see, for example, we have fueling valves, we have check valves, we have service valves, for example, pressure regulators. And these are really, really important to realize or to have really high safety standards. And for sure, also in the infrastructure part, there are these safety relevant metal components. So the question often is, what are the advantages of forged metal components and what metal components can be forged? So the big thing is that internal stress should be avoided in metal components. Finite grained metal structures are recommended, and lower steel hardness is less susceptible to hydrogen embrittlements. And when we take a look at the overall system, you always see that valves play a really important part in these hydrogen overall infrastructure. So, as I said, the powertrains are for vehicles are important. Hydrogen plants, electrolyzers, liquefaction, chemical plants, compressors, pumps are really needed. Hydrogen pipeline and storage systems. Here also valves, regulators, compressors, sealings are needed. The same like in the hydrogen refueling stations. I need these parts. So you see there are a lot of components in such safety relevant structures. And really interesting is that there are no recommendations or guidelines so far regarding the use of forged steel components, so that we have found so far. So this is the really big challenge for the companies now, to define clear guidelines, to define clear standards and norms that can be used for the future hydrogen economy. And as I said, this is a really important point to define such standards. And I also said that these standards can't be defined by one company. It's really need a good community. It needs a really good connections with other companies. It really needs, let's say, a consortium. And as I said, these VALVEcampus for example, is a really good community, I think, to doing maybe some advices, to doing some recommendations, how such a hydrogen economy for valves, what are important or needed standards and norms. I think such a community is really, really important to doing maybe the first steps. And we also saw this in the last years. We saw this also when we spin up, or when we spin off out of the Fraunhofer IPT. So we said a consortium is the key for innovation. And in the last 5 years, we have done 20 of different consortium projects about different topics. There are topics about additive manufacturing, artificial intelligence, but also the fields of hydrogen economy, industrialization of the hydrogen economy. And the approach we have, we try to have companies in such a consortium project, and such a consortium project enable you to tackle potential disruptive changes of your business by providing, for example, overview and structure of a complex and dynamic technology field with technology and economical deep dives, an access to a network of cut-edge research entities and experts, a connection to solution providers and leaders, and for sure what we also try to realize, the utilization of synergies between partners for fast and cheaper implementation. And for this approach, we also now try to build up such a consortium in the field of the hydrogen economy. And how does it look like? It's now an explanation how such a consortium project how is working. You have to think about the mythology behind it. It's more or less a funnel. So we start very bright, very broad, and doing then a deep dive analysis for your specific questions. So we take a look at the market, for example, in the field of hydrogen, where we give you a global overview about relevant products, pilot activities, concepts in the field of hydrogen production, utilization and infrastructure, and derivate the major technical KPIs. For sure, we also take a look at the market forecast, because when we take a look at the different countries, we see completely different, we see completely different forecasts for these countries. For example, in China, we see the focus really is there in the transport sector. China, for example, has the goal to have about 2 million of hydrogen vehicles up to the year 2030, and this is a clear statement, and there's the focus so far. In the USA, for example, hopefully starting next month with this, there's also a lot of now in the discussion of green energy, also green production, and there's a potential step that the USA, that America is going now in. And in Europe, for example, we have in Germany, for example, 9 billion euros to start now to implement the hydrogen production, to start with green hydrogen production with this money. And there's also a lot of money up to, I think there were 100 or up to 500 billion euros to build up such a hydrogen network here in Europe. And I think it's important also to understand how the different countries are working in the field of hydrogen economy, and that it's clear for you what is your part in this hydrogen economy. Then after such a market assessment, let's say, it's really important to understand the technology behind. So to have an overview about components in the field of hydrogen utilization, production, infrastructure. And what is really important to analyze and to identify what are the unsolved technical requirements so far, and what recent trends with a strong view on industrialization potential is reliable, what can be realized. And I think this is a really important point now to understand what are the innovation white spots and what are future field of innovations in terms of design, material properties and production. And finally, we also try to help this company by doing individual hydrogen innovation workshops. So we try to put now the knowledge from stream 1 and 2 to build up for you a specific technology and market roadmap in the field of hydrogen, so that you understand which technologies I really need to understand and which technologies I don't understand, and when these technologies can be used in the market. So in general, we try to help the companies to have an understanding if and how they can participate in such a hydrogen economy. Here is an excerpt of consortium partners we have worked with. So as I said, in the last 5 years, we have 20 of such consortium projects. So we have a lot of partners in these fields, like, as I said, the automotive OEMs, automotive suppliers, but we're also in good contact with material companies like ThyssenKrupp, like Covestro, where we use this net to connect you with these companies. So if you maybe have an interesting development for materials, and for sure, we, beside these industrial network, we also have the field of the research network we built up here in Aachen. We have a really big community at the RWTH campus. We have there approximately more than 200 institutes, not only in the field of hydrogen, but along the whole value chain, more or less. We have a good network also to other communities, Forschungszentrum in Jülich, connection to Belgium and the Netherlands, maybe hopefully also with you in the next months. And we also have good connections also to the politics in general. Here, the National Organization for Hydrogen in Germany, we have a strong cooperation with. We know also where the fundings, so we have good connections also to these ones. So we built up here this network in the last years. So we have a lot of partners in the industrial side, but also a lot of partners in the research part. And this is also our work, let's say, or our statement. We try to be the connection between you, the industry partners, and the research partners. Yeah, one general comment to the project. What is the outline? I think I also introduced this. Beside the information, the technical information, really the benefit is the networking with future potential collaborations. These were a short presentation about the topic scaling up the hydrogen economy. I hope I could give you also some interesting insights, maybe also interesting opportunities, how to be the next steps. And now I will be happy to have a deeper discussion with you if you have any additional questions. Thank you very much.
So yes, we have the first question. You mentioned China as fast, innovative country, but do you think we are competitive with China in the hydrogen sector?
Yeah, it's a good question. So at the moment, what we see, China is doing a lot of technology innovation in the fields of hydrogen, but in general in the field of energy. And as I said, especially in China, the focus is here the mobility. So it's called the mobile PEM-FC, the mobile PEM fuel cell. I would say it's really hard for Europe to be competitive in this sector, but especially in the field of green hydrogen, green energy, here Europe can be really let's say the trendsetter. So here is a lot of technical know-how. There are a lot of companies, in Europe, in Germany, in Italy, that have a lot of know-how in the energy sector, especially in the green energy sector. And it is important for sure to start now with doing this innovation, with developing new technologies. But definitely, I think here is a really big benefit that Europe has in the field of green hydrogen and green energy. And I think here we have a lot of potential.
Okay, the next question is, what are the innovation white spots for one, hydrogen production, and one, hydrogen infrastructure?
The white spots in general for everything is are the costs. So we have to think about new manufacturing or production technologies to realize really, let's say, competitive technologies compared to the state-of-the-art technologies. And especially in the field of infrastructure, for example, tank systems. Here, the question is which materials can be used. So a lot of materials are under developing so far, But for example, the material innovation at the moment is, for example, carbon fibers and stainless steel that are preferred at the moment. But no major material innovations are identified in the recent years. I think here's a really big innovation white spot to developing for hydrogen tanks, for example. Also infrastructure, it's much too expensive. And as I said, there are no standards and norms so far. So it's important to define now standards, to define materials that can be used for my hydrogen economy. And I think these are the major innovation white spots, means the unsolved technical requirements so far.
If you have any further questions, please let me know. Otherwise, we would go to the next question. On your perspective, Mr. Führen, what are the most important factors to scale up a hydrogen economy?
Yeah, the first step is now to scale up really the hydrogen production. So there are a lot of companies also in Europe who are at the moment, like Nel, like Nourion in the Netherlands, like also ThyssenKrupp, for example, who are using these technologies. I think this has to be the first step. And for sure, it has now to be defined also in the utilization sector, where do hydrogen make sense? And we have to do in clear business cases, we have to do in clear products we want to develop. And we don't have to only think about trends in the field of mobility. There's a lot of potential also in the fields of using fuel cells, for example, at home, as a heating source. There's a lot of potential in it. We have to think about different use cases, to think about maybe decentral production processes, so that I can maybe use such an hydrogen overall system for mobile tank stations, for example. And the biggest step now is for sure, and this also go to the politics now, to scale up such an infrastructure that I can also use these hydrogen wherever I want, more or less. So I have to think now where I can fabricate green energy that is used for green hydrogen. And so there are a lot of concepts that has to be used. So for example, the Netherlands and the UK using their offshore parks to create green hydrogen, and afterwards they produce green hydrogen. In Europe, there's a lot of under discussion with Africa, for example, that we produce or that we use a lot of photovoltaics in Africa that can produce the green hydrogen, and that I can directly fabricate also green hydrogen that can be then transported to Europe. And I think this concept has now to be evaluated. This concept has to build up. And I think these are now the first steps in the field of scaling up the hydrogen economy.
Correlated to this, we have another question. What about the use of hydrogen different from automotive? For example, in steel making. Could there be other benefits in more traditional fields, like a request for more nuclear plants?
Yes. So as you said, right, a lot of hydrogen is used for the steel production so far. I think this is also the biggest part so far where hydrogen is needed. Nice that you asked also these questions. I think it was 2 weeks ago. I also had these questions with a plant provider, also with the atomic force provider, who said, okay, I can use this, but I don't have a community for this. I need companies who want to build up these things together with me, and this is one of possible point where you can introduce this. The other point, for example, which is really interesting to think about, a lot of materials, for example, polymers, are fabricating hydrogen as a byproduct. And at the moment, this byproduct, this hydrogen, is not really used. They only use it for heating. And for sure, heating, it's when you use hydrogen for heating, it's really, in principle, expensive. So you can also use this hydrogen maybe for the mobility, maybe for other things. And here are a lot of opportunities where hydrogen really makes sense. And these have to be think about where it makes sense, where are really good business cases.
If you have further questions or you want to refine a question, please let me know.
So otherwise, if you have any additional questions, maybe after when you think about these things, please let me know. You will also get my contact data, I think. And if you have any additional special questions you want to ask in such a big round, please let me know, and I will be also there to discuss these questions with you.
Okay, we have another question. Can 3D printing be an enabler for the hydrogen economy?
3D printing is a technology which has, let's say, a hype 5 years ago. And at the moment, the really good use cases has to be defined. Honestly, at the moment, we don't take a deeper look in these fields, but especially at the beginning, let's say, of the hydrogen field or the hydrogen economy, where we don't talk about large-scale production. Here, it definitely could make sense to integrate 3D additive manufacturing. Maybe also one interesting point we also discussed last times was the field of printing electronics, or printed electronics. So how can I print sensors maybe directly on devices, on sensors? And here we also see that there is a lot of potential in also the field of new innovative sensor solutions, maybe for screen printing technologies that I can integrate cheaper sensors in the field. But at the moment, this is a research field. From my perspective, what I know, these sensors are not at the moment available for hydrogen, but I know there's a lot of underdeveloping in this field of large-scale sensor production for printed electronics. But 3D printing, there is definitely potential. At the moment, when we don't talk about large scales, there I'm right, but at the moment I'm not sure which components maybe are the right component for this, but it's really an interesting point where we have to think about and where we can also have maybe deeper discussion in.
The next, what pressures are we looking at for transport of hydrogen?
So the hydrogen pipelines that are used, it differs a little bit. It's let's say we talk about 50-100 bar. So it's this pressure range. When we talk about the valve, or when we talk about the fuel cell itself, there we talk about between 1 and 20 bar. And when we talk about the storage, then we talk about between 350 and 700 bars. So it's a variety for this, large variety depending on the related product. But yeah, these are the pressure ranges, let's say.
And you talked about green hydrogen from H2O, but what about the O2 economy?
The O2 economy, yeah, it's this is in general where we talk a lot of with for example, like ThyssenKrupp, like Covestro. They also say, okay, this is a really big business, but at the moment, from our perspective, so we are focusing on these hydrogen, these H2O. We saw that there is a big potential, but when we talk, for example, when we have these O2, for example, or CO2, when we want to use the CO2 maybe from the atmosphere, yeah, then we also talk directly. When we combine the CO2 with hydrogen, then we talk directly to synthetic fuels, for example. But if this will come to a market, to a reliable price, I think that will be not reliable, or will not be possible in the next 20 years from our perspective now.
Coming back to transportation, you mentioned pressures, but at what temperatures will the hydrogen be transported?
The hydrogen, it depends for sure a little bit. In principle, I'm not sure really at the temperature, but if you have normal pressures, if you have these with pressure tanks, normal hydrogen, let's say gaseous hydrogen, I think we talk also about room temperature in this field, a little bit colder, but we also talk about now the field of liquefaction, when we have really these liquefaction process, and then we talk about really cold temperatures. Then we talked about minus 200 degrees, and but for sure then we have higher energy densities. And at the moment, this is a really interesting discussion. We also talk about with automotive OEMs, for example, like Daimler, which say, okay, in the future, these cryogenic tanks means cold hydrogen, fluent hydrogen will be maybe the future because of the higher energy density. And for sure, there has to be a lot of developing doing it. And also here in the next 10 years, we don't see that these cryogenious things will have a market readiness. But we also see that a lot of automotive OEMs, for example, are working on these topics of really cold, of cooling hydrogen.
The next question is transport related too. What are typical pipeline diameters for transportation? Does transportation rely on liquid hydrogen too?
So the diameters itself, 1 minute I don't have the clear parameter, but I have here directly a book where I can have this. 1 moment. It is, I think it was in the range of 50 centimeters of approximately, but I will take a look in. Typical diameters are between 100 millimeters and 350 millimeters. And what was the other question?
Does transportation rely on liquid hydrogen too?
I don't understand. So really the question. So
it's not mandatory to transport it in a liquid status.
Yeah. That's right. So at the moment, it's not mandatory. So you also have to think about isolation around it. And at the moment, it's not when we talk about pipeline systems, for example, it's not the case. When we talk about transportation via ships, for example, here liquid hydrogen is playing more and more an important role. And I think this year one company in Japan built up such a ship where you can also transport these liquid hydrogen.
So coming back to the O2 economy, we have energy combined with O2 creates H2 and a lot of O2. So do we have to consider the O2 like a waste?
This O2 as a waste is honestly we don't had this question so far, and at the moment I can't also give you an answer about it. So I also have to think about it. But yeah, I will keep these questions, and maybe I will find some answers for how can I use O2 as a waste product or as a byproduct. It's a good question. I don't know at the moment. If this is not the case, then I have to say thank you very much. And I think I give to you, Virginia, to the last words.
Yes. Thank you all speakers today for their good presentation. Thank you, Daniel and Thomas. The webinar is recorded and will be published on the VALVEcampus YouTube channel. Please subscribe on it. Then follow VALVEcampus on LinkedIn page for ever news to the next webinar. I wish you all a very nice day, and thank you, Daniel and Thomas. Bye-bye.
Thank you very much. Bye.